420 అయినా వస్తుందిరా వచ్చింది ఇది వద్దు అది Hi dear students, good evening everybody. Welcome to this pleasant evening. You can chat in chat box. Your doubts will be cleared. Good evening dear students. Today we are going to discuss about some important reagents which are very useful to you in conversion of the organic compounds. And these reagents, let us see what are these reagents. The most important reagents in organic chemistry and their applications in the conversions we will going to discuss in this today's evening session. Let us see what are these reagents. In this I am going to explain you what is a substrate and what is the action of the reagent on that substrate, then how a reactant will be converted into the product. And here in the organic chemistry I already told you many times that in organic chemistry, we have the importance about RRP. What is RRP? Reactants, reagent, and product. Let us see what is the reactant and what is the action of the reagent and how does it converts into product. Let us see one by one. See, the first one is we will going to discuss about the hydrocarbons. The substrate in this reactions is the hydrocarbons. What are the hydrocarbons? The hydrocarbons is nothing but carbon-carbon, single bond, carbon-carbon, double bond, carbon-carbon, triple bond, as well as the benzene. Then let us see what are the reagent that can be employed during the that is the reaction that undergone by these hydrocarbons. The reagents is said to be these are the 5 reagents. One is said to be the sodium in liquid ammonia. This we call it as the Birch reduction. Another one is the palladium barium sulfate in quinoline. That is called as the Lindlar's catalyst. Another one, third one is said to be the ranitidine. Fourth one is said to be the NBS, N-bromosuccinamide. And fifth one is said to be the carbon monoxide plus HCl in presence of either AlCl3 or CuCl. Let us see what happens when these react, or what is the action of this reagent on the substrate. Let us take the first one, sodium in liquid ammonia. The reduction of sodium in presence of liquid ammonia, we call it as the Birch reduction. In this Birch reduction, the carbon triple bond converts into the carbon double bond. That means here it is a partial reduction. So what is meant by partial reduction? If it is a complete reduction, that is going to be the carbon-carbon single bond. Here, the triple bond is converted into the double bond. That's why I'm saying this is a partial reduction. See what happens here. When a triple bonded compound, when undergo this reduction with sodium in presence of liquid ammonia, anti-addition takes place. Means what? You will get a trans product. See, it is a partial reduction, and in the presence of sodium in liquid ammonia, the product is the trans. That means the two hydrogens, whatever the hydrogens that are adding during this reduction, one is going to be one is going to be add on this surface by breaking up the bond. Another is added on this surface. That means these two hydrogens are added in anti to each other. Therefore, the product is going to be the trans product. Now see other one, palladium barium sulfate. This is also a partial reduction. Then what is the difference between these two? That is, one is sodium in liquid ammonia, we call it as Birch reduction, whereas this reagent is called Lindlar's catalyst. In the presence of Lindlar's catalyst also, the triple bonded carbon is converted into the double bond carbon. Now here, then what is the difference between these two? See, the difference between these two is the syn addition. Whereas in the Birch reduction, there is an anti-addition, therefore trans product. Whereas here, it is going to be the cis product. That means the added hydrogen, whatever the hydrogens are added, they added on the same surface. They added on the same surface, and one bond will be underground. And what you have to remember, you take even in the sodium in liquid ammonia or palladium barium sulfate, you simply remember a partial reduction takes place, carbon triple bond to carbon, carbon double bond. In Birch reduction, trans compound is resulted, whereas in Lindlar's catalyst, cis compound is formed. Let us take this ranitol. This ranitol or platinum or palladium or hydrogenation in presence of these three metals, either carbon-carbon double bond, or if you take the carbon-carbon triple bond, this converts into the carbon-carbon single bond. Means it is a complete reduction. In the previous case, it is a partial reduction, whereas here it is a complete reduction. Then let us see what happens. If you take this compound, here any compound you take, suppose if you take the acetylene, if you take acetylene, what happens? That acetylene contain how many? 3 bonds between the carbon atoms. First, it converts into the what happens? That is a ethylene compound. That is, it converts into the first double bonded compound, and it is followed by ethane. That means in presence of ranitol or platinum palladium in hydrogenation, the final compound is going to be the whether you take alkyne or alkene, finally it will be converted into the alkene. Now let us see other one. See NBS, N-bromosuccinamide. This is what is called as N-bromosuccinamide. And here the compound is N-bromosuccinamide is nothing but this is the compound that is going to be N-bromosuccinamide. Here it is going to be the 5-membered cyclic ring. At one end nitrogen is there, it is double bond O, and this side double bond O, NBr. This is going to be the NBr. This is called N-bromosuccinamide. What is the use of this N-bromosuccinamide? Here it is main the main role of this one is it undergo substitution at allylic position. What is meant by allylic position? You have to know what is allylic position. Suppose a carbon double bond. See, suppose this is the case. Suppose if you write like this is going to be the vinylic carbon. This carbon is called as the vinylic carbon. Suppose if it is one more hydrogen is there here like this, and this is called as the allylic carbon or allylic hydrogens. See the NBS, whereas if you take NBS, that is N-bromosuccinamide, is a substitution takes place. The bromine is added to at allylic position only. It does not disturb here. That is, it does not disturb this alkene or what I meant to say here, the double bond. Simply the bromine is added at allylic position, or it is added to the what is called as benzylic position. This is called as a benzylic position. Here the bromine is added here, not at here. You remember, here it is added to here. That is, whenever NBS is treated with the either here any hydrocarbon, the bromine substitution takes place at allylic position. Now let us take this one. Another one is the carbon monoxide and HCl in presence of AlCl3 or CuCl. And this is nothing but this is called as the Gattermann-Koch reaction. This is called as Gattermann-Koch reaction. See here I wrote it is OCH, CHO. CHO is nothing but this one, aldehyde. In Koch we have the aldehyde group. That's why you remember there will be a product is the aldehyde in Koch, OCH. You remember like CHO. It is a Gattermann-Koch reaction where a benzene is converted into the benzaldehyde in presence of carbon monoxide and HCl in with AlCl3 or CuCl as the catalyst. This reaction is called Gattermann-Koch reaction. Okay, remember this point. What is that point? A clue I am giving here. Koch. In Koch there is a CHO is there, and this CHO is present in our product. That's why you remember in this way. Now let us take the other one, another substrate. Let us say it is haloalkanes and haloarenes. What are the haloalkanes and what are the haloarenes? You know that alkyl halides and alkyl benzene compounds, halobenzene compounds. See, then what are the different reagents that makes action on these haloalkanes or haloarenes? See, these are the 4 different reagents mainly we employed for the conversion. One is alcoholic KOH, another is aqueous KOH, one more is sodamide or lithiumide, another is the sodium in presence of dry ether. See, let us take this, what is alcoholic KOH or aqueous KOH? What is the action of these two? What is the action of these two? The action is nothing but when you take the alcoholic KOH, what happens? There is elimination takes place. That is, when you use the alcoholic KOH in haloalkanes or haloarenes, and we observe there is elimination. What happens here? This is a ethyl bromide. When treated with this alcoholic KOH, you will get ethylene and HBr is removed. That means dehydrohalogenation takes place. And by removal of this HBr, we get, that is, hydrogen is removed from one carbon. Hydrogen is removed from one carbon from here, and bromine is removed from here. So that this both will be removed, and then this bond is converted here, so that you will get the alkene. In the same reaction, suppose if you use the aqueous KOH, what happens? You will get a substitution reaction. See the difference, you must remember this difference. The same reagent, but the solvent is different. KOH dissolved in alcohol, whereas here the KOH is dissolved in aqueous solution. When it is dissolved in aqueous solution, Here it is substitution takes place. When it is treated with alcoholic KOH, elimination takes place. See, this is SN reaction, nucleophilic substitution reaction. When the same ethyl bromide, when treated with the aqueous KOH, you will get the ethyl alcohol. Of course, the bromine is replaced by the that is OH in the, what I meant to say, in the solvent. See, let us take another one is the sodamide or lithiumamide. Sodamide or lithiumide. Now let us see this sodamide or lithiumide. What is the action of this one? Let us see a small technical problem. Okay, let us see here what happened to the sodamide and the lithiumide. See, in this case, dehydrohalogenation takes place. Dehydrohalogenation takes place. Let us see a small technical problem. Okay, let us see. Dehydrohalogenation takes place. Then let us see what happened. If you take, this is what is it? Can you name this compound? 2,3-dibromobutane. When two equivalents of sodamide or lithiumide is taken, what happens here? You can observe that. What is it? Can you tell me what happens? It is 2-butane is formed. You will get 2-butane. 2-butane is the compound. Here what happens? Bromine of one carbon, hydrogen of another carbon, and hydrogen of this carbon and bromine of this carbon. This will be eliminated like this. See, and you remember there will be one hydrogen is there, and here also one hydrogen will be there, and here this hydrogen and this bromine is removed in one step, and another step this bromine and this hydrogen is removed. That's why when you use the two equivalents, then you will get the compound is the 2-butane. Let us take sodium in dry ether. You know, this is a very well known reaction, and all chemistry students can know this reaction. That is, it is called as the Woods reaction. You can chart in the chat box. I can answer if you have any doubts. If you have any doubts, I can answer your doubts also. Okay, nobody. Your charts are not visible to me. Okay, even though. See, sodium in dry ether, what's the reaction? See, ethyl bromide. The two molecules of ethyl bromide, then when treated with the sodium, two molecules will undergo reaction with the sodium, and here the reaction takes place like this. So that a removal of NaBr takes place, two molecules of NaBr takes place. And can you guess what may be the compound product? The product is going to be the butane is the product. Butane will be the product. Now let us see. See, one important thing I want to tell you here. Suppose when two alkyl groups are similar, so that you will get only one compound. You remember one more important is, suppose if you take when it is taken as the methyl bromide. Suppose if you take one is the methyl bromide, another if you take ethyl bromide. Suppose another one is you have taken as the ethyl bromide, that is nothing but C2H5Br. See, this is the mixture of alkanes are formed here. Here, the mixture of alkanes are formed. What are the mixture? See, what happens, you no doubt, there is no doubt, one is a normal compound, that is this Br here, this Br, so that there is no doubt you will get 3-carbon alkane, that is called as the propane. But what happens in a reaction mixture, there are many molecules are present. Therefore, methyl bromide, another methyl bromide will react with the sodium, and you will get 2-carbon alkane, that is called as the ethene. And here another one is ethyl bromide react with another ethyl bromide, and you will get this compound, that is called as the 4-carbon alkane, that is butane. Means when you use two different alkyl halides, you will get the mixture of the alkanes. Minimum 3 compounds are formed, whereas only one alkyl halide is used, you will get only pure compound, that is only one alkane is formed. This point you have to remember. Now let us see, another one is the alcohols, phenols, and ethers. The substrate, alcohols, phenols, and ethers. Then see what are the reagents that can be influence these alcohols, phenols, and ethers. One is said to be the reagents: concentrated sulfuric acid, pyridinium chlorochromate, Another one is said to be the pyridinium dichromate, alkaline KMnO4. Another is said to be the Jones reagent. Let us see what is the action of this reagent on these alcohols, phenols, and ethers. See, the other one, first one is said to be the concentrated sulfuric acid. You know that this is a highly dehydrating agent and highly dangerous acid. I think you know this is called as the king of chemicals. It is very, very dangerous, and it is a dehydrating agent. I think you have some experience regarding the sulfuric acid. In the laboratory, when this a small drop is suppose accidentally placed in your on your clothes or on your skin, definitely there will be some damage you will observe. The reason for that is the concentrated sulfuric acid removes the water either from the clothes or from your skin or anywhere. That's why it will be going to be some damage to the skin and these clothes also. That's why we have to take very high, that is high precautions while handling this concentrated sulfuric acid. Let us see, this is going to be the dehydrating agent. This removes the water. See what is this one? The OH and H, when it is present on the adjacent carbon, what happens? This will be removed. This OH from one carbon, and another one is said to be the H from the adjacent carbon is removed, and alkene is produced. See, another one is said to be the pyridinium chlorochromate. This is said to be the pyridinium chlorochromate. And here PDC means pyridinium dichromate. This is 2 molecules of pyridinium and it is a dichromate. See, the role of this is said to be the partial oxidation. They show partial oxidation means alcohols are converted into the aldehydes. The two, together either PCC or PDC when used, they makes partial oxidation, alcohols are converted into the aldehyde. What do you understand by the complete oxidation? The complete oxidation is nothing but here the aldehyde is also converted into the carboxylic acid. The aldehyde is converted into the carboxylic acid. This is said to be the complete oxidation. But when you use the PCC or PDC, only the alcohols are converted into the aldehyde, and at this stage, the oxidation reaction will be stopped. Oxidation reaction will be stopped. Here similarly, if you take the secondary alcohol, you will get the ketone. If you take the primary alcohol, it will convert into the aldehyde. Whereas if you use the tertiary alcohol, there is no action of the species or PDC. You have to remember this. It is only acts on the either primary alcohols or secondary alcohols. They converted into the aldehydes or ketones respectively. But when treated with the tertiary alcohols, they do not have any reaction. Now with alkaline KMnO4, there is a complete oxidation takes place. That is just now I told you, that is complete oxidation means alcohols are converted into, actually here they are converted into the aldehyde, and aldehydes are converted into the carboxylic acid. That means this stage, that is when it is treated with the alkaline KMnO4, the reaction never stop at this junction. Directly the alcohols are converted, even primary alcohol or secondary alcohol converted in the carboxylic acid. If it is a primary alcohol, you will get the carboxylic acid with the same number of carbons. If it is secondary or tertiary, the carboxylic acid is with less number of the carbon atoms compared to the alcohols. Now let us see what is this Jones reagent. The Jones reagent is nothing but chromium oxide and sulfuric acid acetone. This mixture is called as the Jones reagent. Actually, this mixture will produce a simply chromic acid, that is called as the H2CrO4. This mixture will produce as chromic acid. And this chromic acid will now make some oxidation on this one. This is also full oxidation, that is primary, that is 1 degree alcohols will give the carboxylic acid, 2 degree alcohols will give the ketones, whereas the 3 degree alcohols that is having no reaction. That is primary alcohol give the aldehyde, secondary alcohol will give the ketone, whereas the tertiary alcohols does not undergo any change in presence of Jones reagent. What is Jones reagent? Chromic oxide, that is a mixture of chromic oxide, sulfuric acid and acetone, that is called as the chromic oxide. Now aldehydes and ketones, then what happens in this case? See, we have some very important reagents here, and most of the name reactions, most of the reagents are included in this aldehydes or ketones. Now that is one is dilute sodium hydroxide or potassium hydroxide. Another one is a concentrated NaOH or KOH, Grignard reagent, zinc amalgam and hydrochloric acid. And another one is the hydrazine. This is by mistaken, 2 is missed here. Here, this is going to be the hydrazine, NH2, NH2. And hydrazine, another one is lithium aluminum hydride, sodium borohydride. See, this is going to be the, what happens when an aldehyde or ketone which contain alpha hydrogen treated with a dilute NaOH or KOH, this undergo aldol condensation. What is this aldol condensation? See, the product in the aldol condensation is beta hydroxy aldehyde or ketone, and this undergo a loss of water, and the final product will be alpha beta unsaturated aldehyde or ketone. Aldol condensation or aldol reaction is nothing but the compounds, the aldehydes or ketone which contain alpha hydrogen when treated with the dilute NaOH or KOH, the product is going to be the beta hydroxy aldehyde or ketone, but it immediately loses a water molecule to form alpha beta unsaturated aldehyde or ketone. See, let us see. This is going to be the acetaldehyde where it has 3 alpha hydrogen. You have to remember what is alpha beta. See, this is going to be the functional group. The adjacent carbon to the functional group is called alpha carbon, and the next carbon we call it as the beta and gamma and so on. See, these 2 molecules undergo condensation, and you will get the compound is going to be here also. A small mistake. First of all, you will get here, there will be OH here. And here this is called as the beta hydroxy butanaldehyde, and which converts into the alpha beta unsaturated or unsaturated butanaldehyde is formed. Suppose, see, this is the case. In the case of here, alpha hydrogen. Suppose without alpha hydrogen, if a compound contain aldehyde or a ketone without alpha hydrogen, this undergo Cannizzaro reaction. Then what is the Cannizzaro reaction? It is a self-redox reaction. It is also called a disproportionation reaction. What is this Cannizzaro reaction? When a formaldehyde is treated with the concentrated NaOH or KOH, what happens? It undergoes self-redox reaction. That is, one formaldehyde molecule converted into the, see here, one formaldehyde is converted into the formic acid. Another formaldehyde molecule converts into the methyl alcohol. You remember that one important point, conversion from aldehyde to the carboxylic acid or formic acid is called as the oxidation, and conversion of a formaldehyde into the methyl alcohol, we call it as a reduction. Means a same compound or a single compound undergoing both oxidation as well as reduction. This type of reactions are said to be disproportionation reaction or self-redox reaction. Now let us take the benzaldehyde. It is also having no alpha hydrogen because this is going to be the aldehyde group, and here this carbon is going to be the alpha carbon. This is going to be the alpha carbon, but it is having no hydrogen. That's why when treated with this one, it undergo what is called as Cannizzaro reaction. Now let us see. This is going to be the benzoic acid. That is, one benzaldehyde molecule converts into the benzoic acid. Another benzaldehyde molecule converts into the benzyl alcohol. Therefore, conversion to the benzoic acid is called oxidation, called as a oxidation, and conversion of aldehyde into the benzyl alcohol is called reduction. Therefore, this reaction is an example for disproportionation reaction. Now let us take the Grignard reagent. You remember, when a Grignard reagent is nothing but RMGX. When this RMGX, when treated with the formaldehyde followed by hydrolysis, you will get the primary alcohol. See, this is going to be the formaldehyde when treated with the Grignard reagent. This is an intermediate compound which is formed, which on hydrolysis means which undergo hydrolysis in presence of hydronium ion, means H3O plus, means aqueous solution of the some acid, and you will get what is alcohol? You will get the primary alcohol. But the same reaction when carried with any other aldehyde other than formaldehyde, you will get the secondary alcohol. How does it is? See, this is going to be the aldehyde other than formaldehyde, like acetaldehyde, propanaldehyde, like that. When treated with the Grignard reagent, see, this is going to be an intermediate. Actually, what happens here? You have to remember this double bond will going to break into the single bond, and for one is going to be this R is added here, and here this OMGX is added here onto the oxygen. Therefore, you will get this is an intermediate, and during the hydrolysis, this will give the secondary alcohol. Now, when ketones, when treated with the Grignard reagent, you will get the tertiary alcohol like this. When it is treated, already two alkyl groups are there. One more alkyl group is added in the from the Grignard reagent. Finally, you will get the tertiary alcohol as the product. Now, zinc amalgam and HCl. This is called Clemmensen reduction. See what happens in this case. The carbonyl carbon, that is C double bond O, is changed to the CH2. When it is treated with the zinc amalgam and HCl, this is called Clemmensen reduction. And this Clemmensen reduction is carried in presence of acidic medium. That is, reduction in presence of acidic medium. The carbonyl carbon converts into the what is called as the alkane. For example, if you see this one, this is aldehyde or ketone. If you write hydrogen, it is aldehyde. If it is R is there, that is going to be the ketone. When treated with this Clemmensen reagent, you will get the compound is the alkane. That is C double bond O converts into the CH2. Now let us take an example. The acetone molecule, when treated with this Clemmensen, when undergone Clemmensen reduction, you will get the CO bond is converts into the CH2. That is going to be the propane is formed. And this is another reduction, that is hydrogen in presence of KOH. We call it as the WOLF-KISHNER reduction. What is this WOLF-KISHNER reduction? What happened? Here also the same. The carbonyl carbon changed to the alkane, that is CO changed to the CH2. And here, whereas Clemmensen reduction is said to be the reduction in presence of acid, whereas here it is said to be the reduction in presence of a base. See, the same compound in presence of hydrazine, in presence of KOH, you will get the same, what is it? C double bond will change it to CH. That is acetone changed to the propane. The very small difference between Clemmensen and WOLF-KISHNER is Clemmensen is in acidic medium, WOLF-KISHNER is in basic. The product and the reactants both are same. Now let us take this lithium aluminum hydride. It is a strong reducing agent. Lithium aluminum hydride is a strong reducing agent. It converts C double bond O into CHOH. That is, one hydrogen is added here, another hydrogen is added. One hydrogen is added on the oxygen by breaking up this bond, another hydrogen is added here. That is, an alcohol is resulted. See, aldehydes will give the primary alcohols. This is the case. This is an aldehyde. Therefore, you will get a primary alcohol. Whereas the ketone, they will produce as, what is the compound is? A secondary alcohol. Aldehydes will give the primary alcohols. Ketones will produce secondary alcohols. Now, this is another reagent. See, another one is sodium borohydride actually. This is by mistake. See, you remember this is not, this is going to be the here sodium borohydride. And the sodium borohydride is a weak reducing reagent when compared to the potassium permanganate. Here also it converts C double bond O into CHOH. Aldehydes will give the primary alcohol when treated with the sodium borohydride, and secondary, that is ketones, will give the secondary alcohol. Then what is the difference between lithium aluminum hydride and sodium borohydride? The difference is, see, the difference is when, see, this is an aldehyde functional group is there, here it is a ketone functional group is there, that is here this is an ester functional group is there. That is, this is going to be the ester carbonyl carbon, this is going to be the ketone carbonyl carbon, and this is going to be the what is called as the aldehyde carbon. Among these three, this is highly reactive when compared to here, and this is highly reactive when compared to here. This is less reactive. That's why whenever it is treated with, what I meant to say, see, whenever it is treated with the sodium borohydride, here the aldehyde functional group converts into the alcohols, even ketone functional group converts into the alcohol, but here the ester carbonyl carbon does not reduced by sodium borohydride. This is, you have to remember. This you have to remember. The ester group does not disturb, the ester carbonyl group does not affected by the sodium borohydride. Suppose when it is treated with the, when it is treated with the lithium aluminum hydride, the same reaction when treated with the lithium aluminum hydride, what happens, you know? And this lithium aluminum hydride converts, this is also into OH group. You have to remember. If it is a lithium aluminum hydride, it converts into here. If it is sodium borohydride, this functional group does not disturb, this is not affected. Only this highly reactive carbonyl carbons are affected. And this is the difference you have to remember. Let us take another one is the carboxylic acids and its derivatives. There are two important reagents. One is said to be the soda lime, another is said to be the lithium aluminum hydride in presence of hydronium. Let us see soda lime. Soda lime is nothing but the mixture of sodium hydroxide and calcium oxide. What is the action of the soda lime? The soda lime removes the carbon dioxide, decarboxylation. D means removal, carboxylation means carbon dioxide. Now see, this is what happens. Simply this is going to be removed. This is going to be removed, and simply you will get the alkane is the product. With this, in presence of this, the CO is converted into the sodium carbonate. Another one is lithium aluminum hydride. See, carboxylic acids or esters or acid chlorides, all these are said to be the derivatives. Esters and acid chlorides are said to be the derivatives of carboxylic acid, and they will be converted into the alcohol. I told you already, lithium aluminum hydride is a strong reducing reagent. That's why simply it converts all these compounds into the alcohol. For example, you see RCOH is changed to RCH2OH. This is ester changed to the, see, there are two different alcohols. If you see, observe, this is going to be the one alcohol, this is converts into the another alcohol. And even acid chlorides also convert into the, that is what is called as the alcohols HCl. That means lithium aluminum hydride reduces carboxylic acid esters, acid chlorides into the alcohols. Okay, I want to give you a very important table, a chart. A very important chart. This is very useful to you for all competitive examination. And here, if the carbonyl carbon is changed to the alcohols. This is going to be the alcohol, either it is aldehyde or ketone, whatever it may. Suppose if you write here H, that is going to be the, suppose if you write here H, that is going to be the aldehyde. Okay. And here in the product also you will get this primary alcohol. Ketones will give the secondary and the reduction. See, what is the action of this case? What is the action of lithium aluminum hydride? What is the action of lithium aluminum hydride? See, the action of lithium aluminum hydride is, see, the lithium aluminum hydride can reduces all these compounds. They reduces all these compounds. Whereas the sodium borohydride only reduces ketone and ester. But you remember I told you just now, ester and acids never affected by the sodium borohydride. Only aldehydes and ketones are affected. The acid chlorides also will undergo reduction in presence of sodium borohydride. And if you take the ranitidine will reduces aldehydes and ketones, but they do not affect ester, acid. They do not affect the ester or acid, what I meant to say, ester and acids. See, this is gas. If you take the palladium and carbon, you remember that if you take the palladium and carbon, it reduces only the first two aldehydes and ketones, but they do not affect the esters, acids, and acid chlorides. Dibol H, diisobutyl aluminum hydride, is also a strong reducing reagent, and it reduces all these 5 compounds, that is aldehyde, ketones, esters, acid chlorides. You remember this chart, and it is very useful chart to you. And here, what is action of lithium aluminum hydride, sodium borohydride, ranitidine, which undergo reduction, which does not undergo reduction, will be known from this table. Okay. And I can say that thank you for watching this live session. I hope this is very useful to you. If you have any doubts regarding these reactions or any other reactions in the organic chemistry, you can post in the comment box. I can give you the clarification during any time. You can post anytime while watching this video, and I will give the clarification definitely. I will give the clarification for this. Okay, thank you for watching this.